Hello everyone, myself Anurag Solanki of MCA final year. Today I will be presenting edge computing versus cloud computing, an important concept in distributed systems and a rising trend in modern cloud computing architecture. This presentation explains why cloud alone is not always enough and how edge and cloud together creates powerful hybrid systems. Introduction. Traditional cloud computing has allowed organizations to scale massively using centralized centers. However, with the explosion of IoT devices, billions of sensors are now generating data at the edge of the network. Many applications, such as autonomous vehicle, healthcare monitoring, industrial automation, require real-time response of milliseconds. Sending all this data to a distant cloud server is too slow and too bandwidth intensive. This gave rise to the edge computing, which processed data closer to where it is generated. Together, edge and cloud form a powerful combination for modern digital system. What is cloud computing? Cloud computing provides on-demand access to the computing resources such as storage, servers, database, applications, and analytics through the internet. Cloud is centralized in large data centers, highly scalable and elastic, accessible globally, optimized for large-scale storage and processing. This model is excellent for big data analytics, machine learning, web services, and batch workloads. What is edge computing? Edge computing is a distributed computing model where processing happens at or near the data source. Example includes cameras, IoT sensors, home gateways, and industrial controllers. Edge computing offers local decision making, lower latency, reduced bandwidth use, better performance for time sensitive tasks, real time analytics, and emergency response. Autonomous systems rely heavily on this localized processing. Edge versus cloud. Here is a quick comparison. Latency. Edge provides extremely low latency because data does not need to travel far. Cloud may experience higher latency depending on network distance. Bandwidth. Edge reduce the amount of raw data sent to the cloud, saving bandwidth. Cloud requires uploading large data streams for processing. Scalability. Edge scales by adding more local devices. Cloud scales virtually without limit using pooled resources. Cost. Edge reduce transmission cost, but edge devices may be costly. Cloud follows pay as you go and is cost efficient for large workloads. Use cases. Edge suits for real-time analytics. Cloud suits large-scale data storage and heavy computation. Edge versus cloud hybrid model. The most powerful architecture is a hybrid model that combines both. At the edge, immediate data is processed locally. Only necessary summaries are sent to the cloud. In the cloud, big data analytics and machine learnings are performed. Insights are updated, models are pushed back to the edge. A great example is as a smart city. Traffic sensors make instant decisions at the edge, while deeper analytics and optimization algorithms run in the cloud and sends the updated traffic rules back to the field. Use cases. Edge computing is increasingly used in high-impact real-time system. Example, healthcare ECG monitoring. Wearable device can detect anomalies on the spot and send selected data to the cloud for deeper analysis. Smart traffic system. Edge nodes manage real-time traffic flows, controlling signal based on live data. Real-time video analytics. Edge cameras performs object recognition and security monitoring without sending entire video streams to the cloud. These use case shows why edge computing is a critical extension to the cloud infrastructure. Conclusion. To conclude, edge and cloud technologies are not competitors. They are complementary models. Edge provides instant processing, reduced latency, and smarter real-time systems. Cloud provides unlimited storage, heavy data analytics, and global access. Together, they form the future of distributed computing. This hybrid approach is enabling next generation innovations in IoT, AI, and smart infrastructure. Thank you everyone for listening.